Hello everyone, this is the tutorial to prepare your dental models in Autodesk Meshmixer. I'm going to be showing you how to hollow them out, how to make sure they are sturdy enough to print, and how to make sure that they don't use up as much resin as possible so that you can save some money while still printing it. Now what we're going to do is we're going to open up Meshmixer as we have it here, hit import, you're going to navigate to your file that you're going to be bringing in. This should be one that has come straight out of the app. It should come up as mockup. This is the one that we're going to be using for this tutorial. It is the same one that you will be receiving for the test patient. So you should have one very similar to this. This one already has the templates in place. You will be able to see it as soon as I load it. Now with the model loaded, you can see that this is the original STL right here in the back. If you look around at it, see it's open on the top, and there you can actually see our templates. This is after the design, after the 3D modeling stage, after the sculpting and waxing. Everything has been done to this, so then when you look at the front, it looks quite natural. The ideal. When you actually zoom in, you can see that the templates are right over the original teeth. Now, you cannot print this model as is, because here you have a lip all the way around the model that is way too thin. No printer will print this. It will come up as an error, and it won't let you print something that's usable. So, first order of business is to close the app. We're going to go ahead and select this model, hit edit, and we're going to do make solid right here. When you do that, Meshmixer is going to start calculating and try and fill the hole in the top while trying to retain the actual shape of the model. Now, here we run into our first problem. As you can see, we lost a lot of our detail. A lot. That is because it's trying to make a fast comparison versus the original to the one that it's generating for you. We're going to switch this to accurate. We're going to update, see what our new model looks like. As you can see, it brought back some, but not a lot. Not enough, at least, for us to use. So, what we're going to do, we're going to go to solid accuracy. And you see how it says cell size? The cell accuracy is 0.5 millimeters. We're going to bring it down to 0.1 millimeters. Hit update. Now that it's processed, sometimes you'll get this where you won't see the model immediately. All you have to do is click on the outside and you'll see it will show up. Now, we have brought in a lot more detail. Our last step is to take the mesh density, bring the cell size down 0.15. Update again, and by that time, after processing, we should be almost perfect. Again, we just go ahead and click outside, and you see that now we are back to almost our original resolution of our model. Now we've merged the two pieces, so you'll get a smoother transition. You will have to do some final cleanups once printed, So open up right here, proximals. Have to clean it up a little bit after the print. Now that we have our model perfectly sealed on top and retained maximum amount of our detail, if we bring this cell size up, you will not get this spacing in between. It's just not going to happen. They are too close. You will have to go ahead and come in with a very fine burr and out. We're going to hit accept. And now we have our model right here. This one right here. Close the object browser. And our next step will be to hollow this out. So right here we have the option. It's in the edit box, hollow. Hollow, it will go ahead and automatically calculate. As you can see, it's giving you a transparent outside and it's giving you the solid inside, so you can see how far you are from the actual walls of everything, how much material you're going to be saving. I personally keep this at 1.5 millimeters. You can keep it at 2 if you'd like. Stronger print. 1.5 I find is more than adequate wall towards the outside that we can use. So now that we've hollowed it out, go ahead and hit accept. And we're going to go ahead and use the plane cut tool, the next tool. This is actually going to open up your model. You can see it's going to give you a cross section and it's going to leave a hollowed out piece so that you can save as much material as possible. This big blue arrow is telling you what is going to be cut off, what is going to disappear. What we're going to do is we're going to make sure that the snapping is off. We're going to click the green and we're going to just bring it forward. So we have a fairly level cut. As you can see, I am very, very low. I do not feel comfortable with this. I don't think it'll have structural rigidity, and I don't think it'll have enough space for most dentists to work with. So this saves a lot of material because everything above this won't be there. We should always give a little extra space. So we'll grab the blue and move it up. Just enough so that we have a little bit of ginger on the sides. Like we've cut enough. Here you adjust it so that it is flat. Flat. There we go. That's our cut. Very good. We don't need to worry about this area because we will be working here. It all depends on your design. You know that your designs start front. This one in particular starts right here. Premolar, and a premolar. So these ones in the back don't really need that much material in the back because now that we've predetermined our cut, we're going to hit accept. We're going to delete the part up top. It's going to give us a very clean, printable model. At this point, your model is ready to be printed. All you have to do from this point on is export the model as an STL, just the same way you got it, and take it into your 3D printing software, prepare it, and go ahead and send it to your printer so you can print. Now, we're going to hit File, Save it. Save As is not what you want to do. It will not export. You're going to go down to Export. You're going to name your model. 1. At least this is for mine. You can change yours. We're going to make sure that the Save As type is STL binary. The reason we want binary is because if we do an ASCII file, although it is more stable, it will make a giant file. This file can be anywhere between 80 megabytes to about half a gigabyte. And that is totally unnecessary and will slow down your printing time and slow down your printing software. What we want to do is we want to hit select binary format. Binary format is going to give you a very small file that's more manageable for you to take it into any kind of printing software and be able to process it quickly. I'm going to hit save. It's going to compute, and you have to give it a few more seconds. It's doing everything in the background. I'm going to come down, open up the folder. As you can see, here's my patient 1. And you see it's about 18 megabytes, 17.6 exact. This way you know that this is actually one that we've edited, smaller, takes up less material, and it will print just as strong as if it was a fully solid model. Help. I look forward to seeing you in the next video.